You've probably written a simple for loop 1,000 times, right? You type for item in my under list, and you just trust it to work. Well, today, we're going to pull back that curtain. We're going to look at the powerful engine that makes it all possible, the Iterator pattern. It is, quite literally, the secret language your code is speaking every single day. So, let's start with a bit of a riddle. What on earth could a giant, physical bridge have in common with lines of code on your screen? It sounds kind of weird, but the answer actually gets to the very heart of good engineering. It's all about having a solid plan. See, an architect doesn't just start throwing steel beams together and hope for the best, right? They use blueprints, proven principles that they know will work. And that's exactly what design patterns are for us software engineers. There are blueprints for code. They're not code themselves, but they are a fantastic, reusable solution to problems we all face over and over again. But here's the catch. Just having a blueprint doesn't automatically mean you're going to succeed. Back in 1907, the engineers working on the Quebec Bridge, they were following the patterns of the day. But a tiny miscalculation, a misunderstanding of the principles, led to a total disaster. And that's the key takeaways here. Knowing about a pattern is one thing, but truly understanding how and when to apply it correctly, that is everything. Okay, so let's bring this all back home to something we write without even thinking about it, the good old for loop. We use it to walk through a list, a string, you name it. It just works, almost like magic. But you and I both know there's no real magic in software. There's just really, really clever design. So let's dig in. How does it actually do it? When you write for item in my list, what's happening under the hood? What's the secret conversation that lets the loop grab one item, then the next, and the next, in perfect order, without ever messing up? And here it is, the secret sauce. It's called the Iterator protocol. Basically, your for loop is constantly tapping the list on the shoulder and saying, hey, give me the next thing, by calling this hidden underscore underscore next method. The list hands over an item. This goes on and on until finally the list has nothing left. Then it just raises its hand and says, nope, I'm all out, by raising a stop iteration exception. That's the signal for the loop to stop. That's the whole conversation. Pretty neat, right? So now that we understand the engine, let's talk about one of the coolest ways to use it, comprehensions. If you've used Python for any length of time, you've seen these. They are this beautiful, elegant way to build a whole new collection from an old one, all in just a single, super readable line of code. And the beauty of it is just how clean it is. You want a list? Use square brackets. You want a set with no duplicates? Use curly braces. A whole new dictionary? Same deal. They all use that same Iterator protocol we just talked about to build things super efficiently. But we can push this idea even further. So far, this is all great for stuff that fits nicely in your computer's memory. But what happens when you're dealing with something massive? I mean, imagine a log file that's gigabytes big. If you try to read that whole thing into a list to process it, well, you know what's going to happen. Your program is going to crash. It's a classic problem. So how do we get around it? The solution is to get, well, a little lazy. It's a concept called lazy evaluation. And the whole idea is, why do all the work right now if you don't have to? Instead of reading that entire file all at once, you just process one tiny piece at the exact moment you need it and not a second before. And this is where generator expressions come into play, and they are so cool. Look at this. All you do is change the square brackets from a list comprehension to parentheses. That's it. That one character change completely transforms the behavior. It doesn't build a whole list in memory anymore. Instead, it creates a generator object, a little machine that just knows how to produce the values one by one, but only when you ask for them. This is the absolute key to handling huge data sets with almost no memory. Now, that's awesome for simple one-liners, but what if your logic is more complicated? You know, real-world stuff. That's when we use generator functions. These let us build our own custom-made lazy iterators, and they do it using a keyword that's a total game changer. Okay, we all know return. A function runs, it hits return, gives back a value, and poof, the function is gone, all its memory wiped. It's a one-and-done deal. But yield is different. It's magical. A function hits yield, it produces a value, and then it just hits the pause button. It freezes itself right in that spot, remembering everything, all its variables, and just waits. It's like a function with a memory. So here's how it plays out. You call the function, but it doesn't even run yet. It just gives you this generator object. Then you ask it for the next item. Now it starts running, but only until it hits the first yield. It spits out that value and then goes to sleep.
The next time you ask for an item, it wakes up right where it was and keeps going. It's this incredible cycle of run, yield, pause, run, yield, pause. This is how you can do amazing things like creating an infinite sequence of numbers using almost no memory at all.
All right, let's pull all that together real quick. Design patterns, there are code blueprints. That for loop we all love, it's all powered by that secret handshake, the Iterator protocol. Comprehensions? Just a really slick, elegant way to put that protocol to work. And the real powerhouse? Generators. They give us that lazy superpower for crushing huge data sets with incredible memory efficiency. So I'll leave you with this question to think about. Now that you know about the power of being lazy, of only producing values when you need them, think about your own code, your own projects. Are you processing big files, querying databases, handling data streams? Where can you stop doing all that heavy lifting up front and instead let a lazy approach make your code smarter, faster, and way more powerful?